Ever feel like you're trying to read a secret code when you see all those cybersecurity or business continuity terms flying around?
Oh, absolutely. Happens all the time.
Yeah, you're definitely not alone. So we've gathered a whole bunch of these acronyms, and today's deep dive is really about, making sense of them.
Making sense of them and seeing why they actually matter.
Exactly. Why they're crucial, not just for the tech folks, but really for anyone navigating, well,
hmm
everything today.
Right. We're going to try and cut through that jargon, get to the core ideas. Think of it as um, building up your understanding, the essential defenses, the safety nets in our digital lives, our operational lives.
Okay, where do we start?
Let's start with keeping information safe. Encryption. You hear AES a lot, and ES 256.
Right. AES seems like the standard. So what's the deal with AES 256? Why is that the one people often look for?
Well, AES is the advanced encryption standard. It's the go-to. The 256 part, that just refers to the key length,
Yep.
256 bits, which basically makes it exponentially harder to crack compared to, say, shorter keys, like a combination lock, right?
Right.
More numbers, much harder to guess.
Gotcha. More secure.
Definitely. Then you also hear about things like CBC and CFD.
Okay, those sound a bit more technical, like the inner workings.
They kind of are. They're modes of operation for these encryption algorithms, these block ciphers. CDC, that's cipher blockchaining, it links each chunk of encrypted data together.
Okay.
So if one block gets tampered with, it messes up the ones that follow,
Right.
adds integrity.
Right.
And CFB, cipher feedback, works a bit differently. It processes data in smaller bits, more like a stream, better for, say, live video or audio.
Ah, so different tools for different jobs, but both about keeping the data safe and sound during encryption.
Exactly. Confidentiality and integrity in different contexts.
Okay, so that's locking things down. But how do we know who we're talking to? Who gets the key, essentially? That's authentication, right? Like AH and CHE.
Precisely. Good transition. So AH is authentication header. Think of it like a digital seal on your network traffic.
The seal.
Yeah, it verifies who sent the data and makes sure it wasn't, messed with along the way. Data integrity and origin authentication.
Okay. And threat.
SHIPROG, Challenge Handshake Authentication Protocol. That's more like a secret handshake. It verifies who you are without ever actually sending your password out in the open.
Oh, that sounds much safer.
It is. Much safer way to grant access. Avoids sending those credentials vulnerability.
Makes sense. Okay, so secrets are locked, identities are checked, but what if? What if something goes wrong, those defenses fail? That brings us to terms like ALE and ARO, right?
Yeah.
Sounds like assessing the damage, potentially.
You got it. They deal with risk and potential impact. ALE is annualized loss expectancy. It's basically a formula businesses use
Well, formula for what?
to figure out the likely financial hit from its specific security risk over a whole year. And it uses ARO, the annualized rate of occurrence.
Which is how often the bad thing might happen.
Exactly how often you expect that particular threat to actually occur. So like if a data breach might cost you, say, $100,000 and you figure it might happen once every 10 years.
Then the ARO is 0.1 times per year.
Right. So the ALE would be $10,000 per year. It helps businesses decide where to put their security money, what risks are worth prioritizing.
Okay, yeah, that really puts the cost of not doing something into perspective. We also saw ASLR and ATT and CK. One feels like it's trying to stop problems before they happen, and the other is more about dealing with them.
That's a great way to put it. ASLR, address space layout randomization, is definitely proactive. It shuffles things around in a computer's memory.
Shuffles.
Yeah, it makes it much harder for attackers to predict where specific code or data will be, so they can't easily exploit certain vulnerabilities, like shuffling a deck of cards constantly.
Okay, keeps attackers guessing.
Right. The ATT and CK, that's the MITRE ATT and CK framework. Adversarial tactics, techniques, and common knowledge. It's more of a knowledge base.
A library of bad guy moves.
Sort of. It catalogs all the different methods attackers use, their tactics and techniques. It helps organizations understand how they might be attacked and build defenses against those known methods, more reactive, or maybe helping you react smarter.
Got it. And for all the stuff businesses put in the cloud, CASB is important.
Oh, absolutely. CASB Cloud Access Security Broker. Think of it as a security guard or checkpoint between your users and your cloud services.
Like Office 365 or Salesforce.
Exactly. It enforces security policies, watches for weird user activity, stops sensitive data from leaking out into the cloud. Super important now.
And if the worst really does happen, an incident occurs, is CERT who you'd call?
Often, yes. CERT stands for Computer Emergency Response Team, though sometimes it's CSIRT for Incident Response. It's a dedicated team, experts who handle cybersecurity incidents. They help organizations respond, contain the damage, and recover. A crucial resource.
Okay, let's shift gears a bit. Keeping the business itself running, even when things go wrong. Business continuity, we saw BCP and COPE. Are they the same thing?
Close, but not quite. BCP, business continuity planning, is the big picture. The overall strategy to make sure the business keeps ticking during and after some kind of disruption.
Like a fire or a cyber attack.
Or pandemic, yeah. COOP, continuity of operations planning, is usually part of the BCP. It's often more focused on maintaining just the absolute essential functions during an emergency, especially in government contexts, but the idea applies broadly.
So BCP is the whole plan. COOP is keeping the critical lights on.
That's a good summary.
And BIA and BPA, they help build these plans.
Precisely. BIA is business impact analysis. That's where you figure out which functions are most critical, what breaks first, what hurts the most if it's down, and what are the consequences.
Okay, prioritizing.
Exactly. And BPA, Business Partners Agreement, that's about your external relationships, your key suppliers, your vendors. It outlines who does what to keep things running if there's a disruption affecting you both. Shared responsibility.
Makes sense. Then there's CP and CIR, reacting and improving.
Correct again. CP, contingency planning, is about having specific plans ready for specific types of disruptions. If X happens, we do Y.
The playbook.
The playbook, exactly. And CRR, corrective action report, that comes after an incident or even a drill. It's where you document what went wrong, what was learned, and what specific steps you're taking to fix things and prevent it next time. It drives improvement.
Continuous improvement. Okay, nearly there. We saw a few that looked purely technical, networking stuff, BGP, DPDU, CRC. Quick rundown.
Sure. BGP, Border Gateway Protocol, that's basically the routing protocol of the internet. It decides the best paths for data to travel between big networks. Pretty fundamental.
The internet's traffic cop.
Kinda. Yeah. BPDU, Bridge Protocol Data Unit, is related to network switches. It's part of a system spanning tree protocol that prevents network loops, where data just goes round and round, causing chaos. BPDU helps stop that.
Okay, loop prevention. And CRC.
Cyclical redundancy check. It's an error checking method. When you send data, a CRC value is calculated. The receiver calculates it too. If they don't match, you know the data got corrupted somehow during transmission. Ensures data integrity.
Simple but effective. Lastly, COPE. Corporate owned, personally enabled. That sounds like modern work reality. How does that fit in?
It definitely reflects how many people work now. COPE means the company owns the device, like a laptop or phone, but the employee can use it for some personal stuff too.
The security angle.
Well, it widens the attack surface, right? Personal use means maybe downloading different apps, visiting different websites, which could introduce malware or vulnerabilities onto a device that also accesses the company network and data. So it needs careful policies and management.
Balancing convenience and risk.
Always the trade-off.
Wow. Okay. So from locking down data with AES to keeping the business lights on with BCP, this quick tour really shows these aren't just random letters.
Not at all. They represent really critical ideas, essential concepts for security, for resilience in this, well, pretty complex world we're in.
Understanding even the basics of these terms really empowers you, doesn't it? Helps you grasp the bigger picture.
Absolutely. It lets you participate in the conversation, understand the risks and the protections in place.
So here's a thought to leave you with. Thinking about all these terms we just zipped through, AES, BIA, ATT and CK, all of them, which one do you think actually impacts your daily life or your work the most right now? And maybe more importantly, what questions does that realization spark for you? That could be your next deep dive. Welcome back. Today we're doing a deep dive into, well, what can feel like alphabet soup sometimes. Cybersecurity and tech acronyms.
Yeah, it's quite the list. But they aren't just random letters, are they? They're actually the language that keeps our digital world ticking.
Exactly. It's the shorthand for security, for networking, for how everything connects and stays safe. So our mission really is to decode some of this for you.
And you do see them everywhere. Setting up Wi-Fi, reading a tech article, maybe even in your work email settings.
Yeah.
We usually just skim past.
We do, but understanding them, even a little, gives you a better handle on things. Like, we'll talk about DEP later. Sounds like it takes something away, but it protects.
Or ESP. Not mind reading, definitely not.
Right, or DPO, which almost sounds like a person. Which actually, it kind of is. Let's start with some security essentials. CRL.
Ah, right. Certificate Revocation List. Think of it simply as a blacklist for digital certificates. If a website's security certificate is compromised or expired, it goes on the CRL.
So other systems know not to trust it, like a revoked driver's license, but for websites.
Precisely. And before you even get a certificate, you usually need a CSR.
Certificate signing request. That's the application part, isn't it? You're basically asking a trusted authority, can I have a digital ID, please?
That's it. Then you've got CVE and CVSS. They often go together.
Okay.
CVE, Common Vulnerability Enumeration, is like a dictionary of known security flaws in software, just a unique ID for each one.
Got it. A catalog.
And CVSS, the Common Vulnerability Scoring System, well, that tells you how bad the flaw is. Gives it a score, usually from 0 to 10.
So CVE identifies it, CVSS rates the risk. Makes sense. And FM.
File Integrity Management. This is like a digital watchdog for important system files. It alerts you if they've been changed unexpectedly by malware, for instance.
Keeping an eye on the essentials. Okay, shifting to the attack side of things, CSRF.
Cross-site request forgery. Yeah, this one's sneaky. It basically tricks your browser into sending an unwanted command to a website you're already logged into.
Ooh, so it hijacks your logged-in session somehow?
In a way, yes. Exploits the trust the website has in you. Nasty.
Definitely. But we have defenses, right? Like DEP, which I mentioned, data execution prevention.
Yes, and despite the name, it's a preventative measure. It stops malicious code from running in memory areas that should only contain data.
Blocks exploits that try to inject code where it doesn't belong. Crucial.
Very much so. Now, moving into cryptography. A whole different world of acronyms there.
Oh, yeah. We've got things like DES.
Digital Encryption Standard. That one's a bit of an old-timer now, foundational but largely superseded.
Right, and then the more modern ones, DHE, ECC, DHE, ECDSA, DSA2. It's a mouthful.
It is Diffie-Hellman ephemeral, elliptic curve cryptography, and combinations thereof. The key things here. Ephemeral means temporary keys for each session. Much safer if a key gets compromised later.
So past chats stay secret.
Exactly. And ECC, elliptic curve cryptography, gives you really strong encryption with shorter keys than older methods.
Which is faster and better for, say, mobile devices.
Spot on. Efficiency and strength. Okay, networking side. CSU.
Channel service unit. That's more hardware, isn't it? Connecting your network gear to the main phone or data line.
Yep, that's the bridge. And something you use every day without thinking is DNAT.
Destination Network Address Translation. Okay, what's that doing for me at home?
It's like the receptionist for your home network. You have one public IP address from your provider, but loads of devices inside. DNAT makes sure incoming internet traffic gets to the right device. Your laptop, your smart TV, whatever asked for it.
Ah, the traffic controller. Got it. And ESN.
Electronic serial number, just a unique ID baked into hardware. Less common now than things like IMEI for phones, but the same idea, a unique identifier.
Okay. Then there's authentication, EAP.
Extensible Authentication Protocol. The key word is extensible. It's not one method, but a framework that allows different ways to prove who you are. Passwords, tokens, biometrics. EAP supports lots of them.
Flexible security. And for email, DEM. Sounds important.
Domain keys identified mail. Very. It helps verify that an email actually came from the domain it says it did. Fights off those fake sender addresses, spoofing.
Essential for tackling phishing. Okay, couple more. DPO.
Data Privacy Officer. This is often a person or a team. They oversee how an organization handles your personal data, ensuring it complies with laws like GDPR.
The data guardian. And you mentioned encryption modes, CTM and ECB.
Counter mode and electronic code book. Yeah, these are technical details about how an encryption algorithm is applied block by block. Some modes are more secure than others. ECD, for example, is generally seen as weak for most uses.
Nuances matter in crypto. And finally, DLL and ESP.
DLL is Dynamic Link Library. Think of shared code snippets that lots of Windows programs can use. Saves space and makes updates easier.
Like common tools in a toolbox?
Good analogy. And ESP is Encapsulated Security Payload. This is part of the IPsec protocol suite. It wraps up your data packets traveling over the internet, adding encryption and authentication.
Like a secure envelope for your data in transit. Okay. So, wrapping this up, it's clear these acronyms aren't just jargon. They represent really fundamental building blocks for keeping everything online secure and actually working.
Absolutely. Each one, once you unpack it a little, shows a piece of the complex puzzle running behind the scenes constantly. It's pretty amazing, really.
It is. And I still find DEP and ESP interesting, how tech borrows terms. What's the key takeaway then?
I'd say just start noticing them. In settings menus, in news reports, you don't need to be an expert. But knowing what, say, DKIMAM or FEM generally does gives you a bit more power, more understanding of the digital world you use every single day.
Yeah, empowers you to ask better questions, maybe. And this was just scratching the surface, of course. There's a whole universe out there. Maybe the thought to leave with is, what other vital systems are hiding behind acronyms we just ignore? Ever feel like you're just drowning in alphabet soup? Especially, when tech or security stuff comes up.
Oh, absolutely. It's a common feeling.
Well, you're not alone. Today, we're tackling a list of acronyms a listener sent in those real head scratchers.
It's good.
Our mission basically is to decode the shorthand, give you a better handle on what's actually going on in tech.
Yeah, think of it like this. These letters might seem dry, but understanding them, it unlocks the bigger picture. They're the building blocks.
Okay, let's dive in. First block, networking. We've got GRE, generic routing encapsulation.
Right, so GRE. Imagine you're sending a letter, right?
Uh-huh.
GRE is like putting that letter inside a bigger, sort of more official envelope.
Okay.
Well, it lets different kinds of network traffic travel across networks they normally couldn't. Useful for things like VPNs, for example.
Got it. Like a wrapper.
Ah.
Okay, next, ICMP. Internet Control Message Protocol. Sounds important.
It is in a fundamental way. ICMP is like the network's way of sending basic status messages.
Like when you ping something.
Exactly. That ping request and its reply. That's ICMP. It also handles error messages, destination unreachable and things like that.
So basic network chatter for status and errors. Cool. Then there's IDF, Intermediate Distribution Frame.
Yeah, IDF. Picture like the wiring closet in an office building.
Okay.
The IDS is where all the cables from, say, desks and offices meet up before connecting to the main network gear. It's mostly about keeping things tidy and organized.
The hub for the building's network cables.
I agree.
Makes sense. All right, let's switch gears to security. GCM Galoa Counter Mode.
Right, GCM. This is a mode for encryption. And it's quite clever, actually.
How so?
It doesn't just scramble the data, for confidentiality. It also adds a tag to make sure the data hasn't been tampered with.
Oh, so it's both secret and verified.
Exactly. Lock and seal, basically. Really important.
Definitely. Okay, what about HMAC? Hashed Message Authentication Code. Sounds kind of similar.
Similar goal, authentication and integrity, but a different mechanism. HMAC uses a cryptographic hash function combined with a secret key. So if the calculated code matches on the receiving end, you know two things. The message is unchanged, and it came from someone who knows the secret key.
Verifying the who and the what. Got it. And that brings us to HOTP. I see one-time password in there.
You do. HMAC-based one-time password. It's a way to generate those codes for, like, two-factor authentication.
The ones you get from an app or a little token.
Precisely. But HOTP is event-based or counter-based.
Yeah.
You press a button or the counter increments, and you get the next code in the sequence. It isn't tied to time like TOTP often is.
Right, not time-based. Okay, next. HSM Hardware Security Module. Sounds heavy-duty.
It really is. An HSM is a physical device, like a dedicated box or card.
And its job.
Its whole purpose is to protect cryptographic keys. Think of it like a super secure vault for digital keys. Organizations needing top-level security use these.
A physical safe for secrets. Makes sense. Okay, IPsec. Internet Protocol Security. Sounds broad.
It is broad.
Yeah.
IPsec isn't just one thing. It's a suite, a collection of protocols for securing communications right at the IP layer, the network layer. You can encrypt data, ensure integrity, authenticate the source, the works, like building a secure tunnel over the internet.
It's a secure tunnel, and
Yeah.
IKE helps build that internet key exchange.
Exactly right. IKE is the negotiator. It's the protocol that sets up the security parameters and exchanges the keys needed for that IPsec tunnel, the initial handshake, basically.
Okay. We also have IV on the list. Initialization vector. What's that initialize?
Good question. In encryption, particularly with block ciphers, you need randomness. An IV is a random or semi-random number used to start the encryption process.
Why?
It ensures that if you encrypt the same piece of data multiple times with the same key, you get different results each time. Adds a crucial layer of security. Makes patterns harder to spot.
Prevents predictability. Smart. Next up, KDC. Key Distribution Center. That's part of Kerberos, isn't it?
Correct. In Kerberos authentication systems common in big networks like Windows domains, the KDC is the trusted central server. It manages and hands out the secret keys and tickets that users and services need to prove their identities to each other securely. It's the central authority.
Got it. And GPG, New Privacy Guard. I think I've actually used that.
Very possible. GPG is popular software. It's free and open source. It implements the OpenPGP standard for encrypting and digitally signing emails, files, data.
Oh.
Lets individuals manage their own security.
Right, for personal encryption. Okay, shifting slightly. Identity. IDP. Identity provider.
An IDP is the service that, well, manages and asserts your identity online.
Like when I log in with Google or something.
Exactly. When you use sign in with Google or log in with Facebook on another site, Google or Facebook is acting as the IDP. They tell the other site, yep, we know this person, they are who they say they are.
Makes single sign-on possible. Okay, now some big organizations, i.e. an ISO, standards bodies.
Yep. Institute of Electrical Electronics Engineers, huge professional org. They set tons of standards, especially for networking, like Wi-Fi standards, 802.1 something.
Oh, right, an ISO.
International Organization for Standardization, much broader. They develop standards for almost everything, from quality management to information security. Lots of industries, not just tech.
The rule makers, essentially. Okay, data protection, GDPR is a big one.
Huge. General Data Protection Regulation. That's the EU law governing data privacy and protection. It sets strict rules for handling personal data and gives people more control. Big impact worldwide, really.
Yeah, definitely. And GPO,
Huh.
group policy object. Sounds like Windows.
It is. In Windows environments, GPOs are how administrators manage settings for users and computers across the network. Things like password policies, software restrictions, desktop settings, all managed centrally.
For consistency and control. Got it. Now some hardware and infrastructure buzzwords. FPGA.
Field Programmable Gate Array. It's a type of chip you can reprogram after it's made. Very flexible for specialized tasks.
Okay, GPU, graphics processing unit. For games.
Originally, yes. But now GPUs are powerhouses for parallel processing. Used heavily in AI, scientific computing, crypto mining, anything needing lots of calculations done at once.
Way beyond just graphics now. Then IS.
Infrastructure as a service. That's a cloud computing model. You basically rent the fundamental IT building blocks, servers, storage networks from a provider like AWS or Azure.
You rent the hardware, essentially.
In IEC. Infrastructure as code. This is a big shift. Instead of manually clicking around to set up servers and networks, you define your infrastructure using code.
Like programming your setup.
Pretty much.
Yeah.
You use configuration files or scripts. Makes things automated, repeatable, consistent, version controlled. Very powerful.
I can see that. Okay, almost there. IDEA. International Data Encryption Algorithm.
IDEA. It's a specific type of encryption algorithm, a symmetric key block cipher. Less common now than AES, but part of the history.
Got it. And FRR. False rejection rate. Sounds like a system messing up.
It is. In biometrics like fingerprint scanners or facial recognition, FRR measures how often the system incorrectly rejects a legitimate, authorized user. You want this number to be low, obviously.
Yeah, you don't want to be locked out when you shouldn't be. Okay, last one. IRC. Internet Relay Chat. Blast from the past.
Totally. It's one of the original text-based chat protocols. Been around forever. Still used by some tech communities, but definitely old school compared to modern chat apps.
Wow. Okay, that was quite the sprint through the alphabet soup. Hopefully that clears up some of those acronyms for you.
Yeah, and remember, this was just a quick look. If any of these, caught your attention, definitely dig a bit deeper. Just knowing a few can really help navigate tech discussions.
Absolutely. Knowledge is power, right? So, thinking about all that, what previously opaque tech concept might you feel ready to tackle next? Welcome along to this deep dive.
Great to be here.
Today, we're tackling tech acronyms. You know those strings of letters you see everywhere?
Yeah, they can be pretty confusing.
I've got a list here, just a simple source list. And our mission really is to decode them.
Exactly. Not just spell them out, but explain what they actually do.
And why you might actually run into them.
Right. Give some context.
Okay, let's maybe group some. How about security first?
I see. OCSP?
OCSP, that's Online Certificate Status Protocol.
Okay. And in plain English?
It's like a quick online check. Is this website's security ID, its certificate, still good?
Okay.
Or has it been, revoked?
Got it.
Right.
Like checking an ID card hasn't expired.
Sort of, yeah. Then there's OVAL.
OVAL.
Open Vulnerability Assessment Language.
Yeah.
It's basically a standard way to list out known software security flaws.
The security tools can understand the same list of problems.
Exactly. Makes things consistent. And then we have PAM.
Okay, PM. Now, the list has two for this, which is interesting.
It does. First is Privileged Access Management. Big topic. Right, controlling who gets the God mode access, the admin rights.
Precisely. Super critical. But the other PM
Is Pluggable Authentication Modules. Sounds techy.
It is, but it's clever. It's like a framework behind the scenes. It lets a system easily swap out how it checks who you are.
So it could use a password check or a fingerprint check or something else without rewriting the whole login system.
Got it. Very flexible. Context is key to know which PAM is being discussed.
Makes sense. Okay, still on security. PBKDF2.
Password-based key derivation function too. Sounds complex.
Definitely does.
But the idea is simple. Make guessing passwords really, really slow and hard for attackers. It adds extra computational work.
So it beefs up password security.
Massively. Then there's PCI DSS. You've probably seen this one.
Payment card industry data security standard. Yeah, often see PCI compliant on payment pages.
Exactly. It's the rule book for anyone handling your credit card data online. Keeps your info safer.
Good to know. Beep beep.
Protected Extensible Authentication Protocol. Often used for Wi-Fi security, like in universities or workplaces. WPA2 Enterprise often uses it.
Right, secure logins for Wi-Fi. And the last security one here is PFS.
Perfect forward secrecy.
Oh,
This is really neat.
okay.
It means that even if someone steals the current key used to encrypt your messages, they can't use it to go back and decrypt your past messages. Each session gets a unique key that's discarded.
Oh, that's smart. So a breach today doesn't compromise everything from yesterday.
It's exactly a very important security layer.
Okay, let's switch gears. Networking stuff. OID.
Object identifier. Think of it like a unique serial number or address for, well, almost anything manageable on a network. A specific device setting, a piece of data,
Like a very precise label.
a globally unique one, yeah. Then OSINT.
Open source intelligence. This feels broader than just tech sometimes.
It absolutely is. It's gathering info from public sources, websites, news, social media.
In tech, maybe looking for public data leaks or system info.
Exactly. Using what's out there to understand risks or targets. Then OSPF.
Open shortest path first. Sounds like directions.
It kind of is. It's a routing protocol. It helps data find the most efficient path across complex networks, like a GPS for data packets.
Okay. OT. Operational technology.
Yeah, this one's important to distinguish from IT, information technology.
IT is the office, computers, servers, business apps.
Right. OT is the tech that controls physical stuff. Think factory machines, power grids, building controls. Industrial control systems are a big part of OT.
Got it. Different world, different risks. OTA.
Over the air. You definitely know this one.
Software updates. For my phone, my car.
Yep. Any update delivered wirelessly. PAT.
Port address translation.
This is often used in your home router. It lets all your different devices, laptop, phones, smart TVs, share your single public internet IP address.
That's how they all get online through one connection. And PBX.
Private branch exchange.
Yeah.
Basically a company's internal phone system. Handles calls within the office and routes external calls. Might be a physical box or cloud-based now.
Okay, that covers a lot of how things connect. What about file types? P12.
P12 or PKCS is STAG 12. It's a file format. Usually holds a digital certificate and its corresponding private key together, often password protected.
So a secure bundle for digital IDs. PCP.
Packet capture. This is a file that contains a recording of actual network traffic.
Why would you need that?
Oh, for troubleshooting network problems, or for security investigations, seeing exactly what data went across the wire.
Essential tool for network folks then. PEM.
Privacy-enhanced mail. Despite the name, it's mostly used now as a very common text-based format for storing crypto keys and certificates. You often see files ending in .pm, .crt, .key.
So P12 is a binary bundle. PEM is often text-based.
Generally, yeah. Different ways to store similar things.
All right, nearly there. Some concepts. P2P.
Peer-to-peer. Instead of everyone connecting to a central server, devices connect directly to each other.
Like old file sharing systems or some blockchain tech.
Exactly.
Then PASI.
Platform as a service. Cloud stuff. Right. It's like renting the whole workshop, not just the tools or the finished product. You get the operating system, databases, development tools. You build and run your apps on their platform.
But you don't manage the deep infrastructure.
Correct. They handle the servers, storage, networking underneath,
Asli.
and PEC.
Proxy auto-configuration.
Yeah, it's usually a little script file that tells your web browser automatically which proxy server to use for different websites, often used in big organizations.
To control or monitor web access.
Usually, yes. Finally, just two hardware ones. PDU.
Power distribution unit. Sounds like a power strip.
A very fancy, heavy-duty power strip for server racks and data centers. Manages and distributes power reliably.
Okay, much more industrial. And PED.
Personal electronic device.
That's just anything.
Pretty much your smartphone, tablet, laptop, anything electronic and personal.
Simple enough. Wow, that was quite a list.
It was, but hopefully less intimidating now.
Oh.
Understanding these just gives you a bit more insight into the digital systems we use constantly.
Absolutely. So when you see, I don't know, PCI DSS or you get an OTA update, you have a little more context for what's happening under the hood.
Right. It demystifies it a bit.
So for final thought, start noticing these acronyms. When you see one, just pause and think about the system or the process it represents. You might be surprised how often they pop up and what they tell you about how things work.
Yeah. Connects the letters to the real world. Ever feel like the world of tech speaks a different language? Like, totally different sometimes.
Oh, absolutely. It's filled with jargon.
Exactly. So today, we're tackling a listener request. We're going to decode a bunch of tech acronyms.
Alphabet soup,
Can you
basically.
imagine? Our mission is to make sense of it all so you can navigate the digital world with a bit more confidence.
Sounds good. We've got the list. We should probably just dive in.
Yeah, let's do it. We'll look at what they stand for and, maybe more importantly, why they actually matter. Okay, first up, security and privacy stuff.
Right. And these are really connected. Let's start with PGP. Pretty good privacy.
Oh.
It's basically an encryption standard. Think email, mostly. It scrambles your messages so only the right person can actually read them.
Crucial for anything sensitive online, yeah.
Totally. Then you have things like PHI and PII.
Right. Heard those a lot.
PHI is personal health information, so your medical data. And PII is personally identifiable information. That's, your name, address, social security number.
The stuff hackers love, unfortunately.
Exactly. That's why data breaches and privacy laws are such a big deal, protecting that PII and PHI.
And what about PIV?
Ah, PIV, personal identity verification. It's like a really secure ID card, often used for government or high security access, making sure it's really you.
Got it. So digital locks and keys for our personal stuff, essentially.
That's a good way to put it.
Okay, building on that, let's talk cryptography and authentication.
Huh.
PKCS and PKI sounds like a law firm.
Huh. Yeah, it does a bit. But no, PKCS stands for Public Key Cryptography Standards. Think of it as the rule book for how secure communication should work digitally.
Okay, the standards.
And PKI, Public Key Infrastructure, that's the whole system that actually implements those rules. It manages the digital certificates, the public and private keys.
Ah, the keys. So that's where that comes in, like a digital passport system?
Kind of, yeah. It verifies identities online.
Yeah.
Then there's PSK,
BSK.
pre-shared key. Much
Yeah.
simpler. It's like your home Wi-Fi password. Everyone connecting uses the same secret key.
Okay, makes sense. And RC4.
RC4 is Rivest Cipher version 4. It's an older encryption method. A bit outdated now. You wouldn't really rely on it for strong security today. Think of it like an old lock.
Right, better options available now. So all this is this sort of invisible plumbing keeping things secure online, mostly.
Mostly, yeah. It's
Right.
complex.
Definitely. Okay, switching gears, networking basics, POTS. That sounds really old.
It is. POTS stands for plain old telephone service.
Your landline.
Exactly. Your classic dial tone phone line. It's, well, a good baseline to see how far we've come.
For sure. What about PPP and PPTP?
Right. PPP is point-to-point protocol, and PPTP is point-to-point tunneling protocol. These are older ways to create a direct, sort of secure-ish connection between two computers.
Like a private tunnel for data?
Kind of. You might have seen PPTP used with older VPNs, maybe.
Okay. And radius.
Radius remote authentication dial-in user service. Think of it like a central security guard for a network. When you try to connect, maybe remotely, Radius checks your username and password before letting you in.
Ah, the gatekeeper. Got it. All right, next up, storage and system management. RAID, RAS, and RAD. Interesting mix.
Yeah, quite a trio. RAID first, redundant array of inexpensive disks, or independent disks sometimes.
Okay, what's that for?
Data safety mostly. It uses multiple hard drives together. So if one drive fails, your data isn't lost, the others have copies or parts of it. Super important for reliability.
Okay, avoids disaster. Now, RAS and RIA sound similar.
They do, but they're very different. RAS often means remote access server. That's legitimate. It lets you connect to a network from afar, like for remote work.
Useful, but RAT.
RAT is bad news. Remote access Trojan. It's malware, a nasty piece of software that lets hackers sneak in and control your computer remotely.
Yikes. Okay, definitely want RAS, not RA. What about RBAC?
RBAC can actually mean two things, which is slightly confusing.
Oh, great.
It can be role-based access control, meaning your permissions depend on your job title or role. Or it can be rule-based access control, where access depends on specific rules, like time of day or location.
But both are about managing who gets access to what, right?
Exactly. Controlling permissions. And RA can also have two meanings.
Oops, it can.
Right. Recovery agent, someone authorized to recover encrypted data if you, say, lose the key. Or registration authority, an entity that verifies your identity before you get a digital certificate, often part of that PKI system we mentioned.
Okay, so context is key there. Finally, a few miscellaneous ones. PTC.
PTZ is pan tilt zoom. Think security cameras, the ones that can move left and right, up and down, and zoom in remotely.
Ah, yeah, see those everywhere. PUP.
PUP means potentially unwanted program. It's not necessarily malicious like a virus, but it's software you probably didn't mean to install and might be annoying. Show ads or install other junk.
So something to watch out for during software installs.
Definitely. Then there's RACE, that was a European initiative, Research and Development in Advanced Communications Technologies in Europe, more of a historical project name.
Okay. And RAD.
RA is Rapid Application Development. It's a software development methodology focused on building applications quickly, often using prototypes and iterating fast.
Gotcha. Okay, wow, that was a lot of acronyms.
It was quite the list.
So what's the big takeaway for someone listening?
Well, I think it's that, yeah, these acronyms like intimidating, like a foreign language, but they just represent specific ideas, specific technologies, the building blocks of our digital lives, really.
Right, they're not just random letters.
Exactly. And understanding even a little bit about them, like knowing what PII is, helps you be more aware,
Yeah.
more conscious of what data you're sharing, why those privacy settings matter on websites.
That's a really good point. It empowers you, makes you a bit more savvy online.
Precisely.
So maybe a final thought.
Mm.
As you bump into these weird tech terms out there, maybe jot them down, let us know. Perhaps the next deep dive can tackle your list of confusing acronyms.
Sounds like a plan.
Awesome. Well, thanks for tuning in, everyone.
Ever feel like the tech world speaks a totally different language, just acronyms everywhere?
Oh, absolutely. It can be overwhelming.
Yeah, you're definitely not alone if you feel that way. So today we're doing a deep dive, trying to throw you a lifeline with a list of these tech abbreviations.
Right. The goal isn't to bury you in jargon.
Exactly. We want to demystify them, give some context, maybe spark a few aha moments. We've got this list and we're just going to talk through it.
Sounds good. Think of it as, I guess, a cheat sheet. We've grouped them a bit thematically to help make connections. Let's maybe start with networking.
Okay, good place to start, connecting things. So first, there's RDP, Remote Desktop Protocol.
Right, that's the one for accessing your computer from, well, somewhere else.
Yeah, you see its screen, you control it, pretty useful. Then RTP, Real-Time Transport Protocol.
Ah, yes. Crucial for streaming, like video calls, music. Keeps the data flowing smoothly. The unsung hero, you called it.
It really is. Now, scaling up, connecting whole networks, SD-WAN, software-defined wide area network.
Mm-hmm. This is big for businesses with multiple sites. Instead of relying purely on physical hardware configuration.
It uses software for control, makes things way more flexible.
Right.
Maybe cheaper.
Often, yeah, more adaptable. And that whole idea comes from SDN, software-defined networking. Applying that software first, thinking more broadly to network management.
It's really about software giving us finer control over how everything connects.
Precisely. Smarter, more adaptable.
Yeah.
But as things get more
The
connected.
security becomes paramount. Yeah.
Exactly.
Yeah.
Which brings us to a whole bunch of security acronyms. Let's see, RFID, radio frequency identifier.
Oh, yeah, key cards, tracking inventory, that kind
Yeah.
of thing. Uses radio waves.
Simple, but effective.
Yeah.
Then something more complex, RIPE-MD, Race Integrity Primitives Evaluation Message Digest.
Okay, that's a mouthful. Like a digital fingerprint for data integrity.
That's a good way to put it. Ensuring data hasn't been tampered with. Then there's the classic, RSA, Rivest, Shamir, and Adelman.
A cornerstone, right. Public key, private key stuff for secure communications.
Absolutely fundamental. Keeps lots of online interactions confidential.
Okay, practical defense now. RTBH, remotely triggered black hole. Sounds cool.
It kind of is. Think of it like a network defense mechanism. If it detects bad traffic.
It just redirects it into nothingness. A digital void.
Pretty much. Shuts down attacks quickly. Then for emails, SME. Secure multi-purpose internet mail extensions.
So encrypting emails, adding digital signatures, making sure it's really you and it's private.
Correct. And for Wi-Fi. When you connect securely, sometimes SAE is involved. Simultaneous authentication of equals.
Part of that secure handshake between your device and the network.
Exactly. And managing logins across different services.
Yeah.
Security assertions, markup language.
The single sign-on thing, so you don't need a million passwords.
That's the idea. Makes life easier, potentially safer. And, the little lock icon in your browser, HTTPS.
Yeah.
Part of that involves SAN, subject alternative name, lets one security certificate cover multiple website names or addresses.
Okay, useful for website admins.
Very. What's interesting now is seeing how these things merge, like SaaS Secure Access Service Edge.
Right, I've heard about that. It combines networking and security.
Yeah, often as a cloud service. It reflects how we work now remotely, accessing cloud apps.
So security needs to follow the user, not just the office building.
Precisely. And to keep everyone on the same page for security checks, there's SCA, Security Content Automation Protocol.
Standardizing security assessments makes sense. For Linux users, CLinux. Security enhanced Linux.
Mm-hmm. Adds extra security right at the operating system kernel level, more layers.
And protecting the data itself, even if someone steals the physical drive. SEDs, self-encrypting drives.
Built-in hardware encryption
Yep.
automatically scrambles the data. It shows how security is really multi-layered.
Totally. Okay, shifting gears. What if, despite all that security, things still go wrong? Disaster recovery.
Right. Important topic. You hear about RPO, Recovery Point Objective.
That's about data loss, right? Like how much data measured in time can you afford to lose? An hour's worth, a day's worth.
Exactly. It defines the maximum acceptable data loss.
Hmm.
And linked to that is RTO, Recovery Time Objective.
How fast do you need to get back online after a disaster? Minutes, hours?
Yep. How quickly systems need to be restored, crucial for business continuity. And where does all this data live? Sometimes on a SAN storage area network.
Okay, wait, we had SAN for certificates earlier. Subject alternative name. This is different.
Ah, yes. Good catch. Acronym overload. This N is storage area network, a dedicated high-speed network just for connecting servers to storage devices. Think big data centers.
Got it. Storage area network. Okay,
Yeah.
let's touch on building things. SDK, software development kit.
Ah, the developer's toolkit. Contains the tools needed to build apps for a specific platform, like Android or iOS.
Makes sense. And managing that building process. SDLM, software development lifecycle methodology.
Like a blueprint or framework for developing software. Waterfall, Agile, those kinds of things fall under this.
Okay. And some systems need to react instantly, like industrial controls, RTOS, real-time operating system.
Critical for time-sensitive applications. Think cars, medical devices, factory automation. Timing is everything.
Which leads to SCADA, supervisory control and data acquisition.
Right. Used in those industrial settings, power plants, manufacturing to monitor and control processes.
And one last one, related to certificates again, SCEP, Simple Certificate Enrollment Protocol.
Yeah, helped automate getting and managing those digital security certificates we talked about. Makes it easier to handle them at scale.
Wow, that was quite a tour through the alphabet soup of tech.
It really is an ecosystem, isn't it? Tools,
Mhm.
protocols, security layers, development processes.
Definitely. Hopefully this deep dive helped connect some dots, made these acronyms feel a bit less, intimidating.
Yeah, you don't need to be an expert in all of them, but just having a basic grasp can make navigating tech conversations much easier.
It provides a foundation, maybe points you towards areas you want to learn more about.
Exactly. This was just a starting point.
So, thinking about all this and how fast tech keeps changing, constantly throwing new abbreviations at us, what strategies do you find work best for staying informed without just feeling totally overloaded? Something to think about.
A great question to ponder.
Thanks for diving deep with us today.
Welcome to the deep dive. We had a listener ask us, basically, what on earth do all these tech acronyms mean? You sent in quite a list.
Yeah, it's a good one. A real alphabet soup of security and tech terms.
Exactly. So, our mission today is to cut through that jargon, figure out what they actually stand for, and, why they matter.
Right. If you've ever felt a bit lost with all these initialisms, well, this is for you. We're aiming for those aha moments without getting too bogged down.
Let's do it. First section seems to be about secure communication, SFTP. Kicks us off.
SFTP. Okay, think secure file transfer protocol. It's like sending a package, but in a locked box online.
Ah, so it encrypts the files while they're moving.
Precisely. Unlike maybe older ways. Keeps things private. Then there's SHTTP.
Secure Hypertext Transfer Protocol. Sounds like HTTPS.
Very similar concept, yeah. It's
Yeah.
about adding that security layer to web browsing, though HTTPS is, much more common now. It paved the way.
Gotcha. And SRTP, Secure Real-Time Protocol.
That one's key for, like, secure voice calls, video conferencing online.
So, keeping Zoom calls private.
Basically, yes, ensures the stream itself is encrypted. Okay, then we've got STIX and TAXTI together.
Right, these sound technical. STIX.
It stands for Structured Threat Information Exchange. It's like creating a common language, a standard format for describing cyber threats.
So everyone's speaking the same threat language.
Exactly. And TAXTI trusted automated exchange of indicator information. That's the secure pipeline for sharing that STIX data.
So STIX is the message. TaxTie is the secure delivery van.
Good analogy. It means organizations can share threat intel faster and more automatically. Helps everyone defend better.
Makes sense. Okay. Shifting to security measures themselves. SHA, secure hashing algorithm.
Think of SHA as creating a unique digital fingerprint for data.
A fingerprint.
Yeah, a hash. If even one tiny bit of the data changes, the entire fingerprint changes dramatically. It's used to check if data is, like, intact and hasn't been messed with.
Very clever. Okay, next. SOR, security orchestration automation response. That's a big one.
It is, and it's pretty powerful stuff.
Yeah.
SR platforms help security teams automate a lot of their repetitive tasks.
Like responding to basic alerts.
Exactly. It takes a sequence of actions automatically. It frees up the human analyst to focus on the really complex, tricky threats, improves response times too.
Efficient. Okay. What about SWG, secure web gateway?
SWG. Think of it like a security guard and filter for an organization's internet access.
So it checks web traffic.
Yeah, incoming and outgoing. It blocks access to malicious sites, scans downloads for malware, enforces company policy, that kind of thing.
Essential nowadays. Then TPM, trusted platform module.
Right. You often see that in laptop specs. It's actually a dedicated hardware chip inside the device.
Hardware. Okay. What does it do?
It securely stores things like encryption keys, passwords, certificates. Because it's hardware, it's more resistant to software-based attacks trying to steal that sensitive info. Adds a root of trust.
Got it. And TOTP, time-based one-time password. Most of us use these.
Oh yeah, those codes from authenticator apps or key fobs.
The ones that change every 30 or 60 seconds.
Exactly. That time-based element is key. It means even if someone steals the code, it expires really quickly. Great for multi-factor authentication.
Definitely adds a layer. Okay, TGT. Ticket granting ticket? Sounds like entry to something.
It kind of is. It's often part of systems like Kerberos. Once you log in initially, you get a TGT.
And that ticket lets you.
It acts like a temporary proof of identity, letting you access other services on the network without having to enter your password over and over again. It's a convenience and security thing.
Makes sense?
Yeah.
Then TKKP, temporal key integrity protocol.
TKP. You might remember that from older Wi-Fi security settings like WPA.
Yeah, I think I do. Not used much now.
Not really, no. It was an improvement at the time, but vulnerabilities were found. It's been superseded by stronger protocols like WPA2 and WPA3 using AES encryption. Shows how security has to keep evolving.
Good point. Okay, authentication and authorization next. SIM, subscriber identity module.
Yep, the little card in your phone. Or, increasingly, an eSIM.
That identifies you to the mobile network, right?
Correct. Holds your unique subscriber info. Then there's TAC-AXIS Plus. That's a mouthful.
Terminal access controller, access control system. Plus. What's the plus?
Yeah. TAC-AXIS Plus is a protocol mainly used for network devices like routers, switches, firewalls. It centralizes control over who can log in. That's the authentication part.
Okay.
And what commands they're allowed to run once logged in. That's the authorization. The plus indicates it's an improved version over older TAC-AS.
Central control for network gear. Got it. Moving into IT management, SLA.
Service level agreement. This is really important in business.
It's the contract between a service provider and a customer, right? Defines expected service levels.
Exactly. Specifies things like uptime guarantees, response times, performance metrics, what happens if they aren't met.
In SOW, statement of work.
SOW usually details a specific project. The deliverables, the scope, timelines, tasks involved. It's more granular than an SLA usually.
Okay. Project specifics versus ongoing service levels. Makes sense. Now, some threats.
Spam. Sounds unpleasant, doesn't it? It's spam over internet messaging.
Like junk messages on chat platforms.
Precisely. Unsolicited commercial messages, but via IM instead of email. Annoying and sometimes malicious.
Right. Squal. SQL injection. This sounds bad.
It is bad. SQL, structured query language, is used to talk to databases. SQL injection is an attack where someone tries to sneak malicious SQL commands into input fields.
It's like a login form or search box.
Yeah, exactly. If the application isn't coded carefully, those malicious commands can trick the database into revealing data, deleting data, or worse. It's a very common web attack vector.
Ouch. Okay. SLE. Single loss expectancy. Sounds like risk assessment.
It is. It's a calculation used in risk management. Basically, what's the expected monetary loss each time a specific bad thing happens? Like, if a server fails, what's the average cost? Helps prioritize security spending.
Calculating the cost of failure. Okay. And then TOC and TOU. Time of check, time of use.
Right. These often go together. They relate to a specific type of software bug called a race condition.
Raise condition.
Yeah, it's about timing. Imagine software checks if a user has permission to do something. Time of check. But then, before it actually performs the action, time of use, something changes, maybe the user's permissions get revoked. If the timing is just right, the action might still go through incorrectly. It's a tricky vulnerability.
Wow, yeah. Timing issues in code. Okay, last few are foundational tech. SQL, again, structured query language.
Yep, we mentioned it with SQL. It's the fundamental language for managing and querying data in relational databases. Super common.
Then SEH, structured exception handler.
This is about how software deals with errors, like unexpected problems or crashes. SEH provides a structured way for programs to catch these errors and handle them gracefully, maybe log the issue, instead of just crashing completely.
Better error handling. Good.
Huh.
And finally, SMS. We all know this one.
Short message service. Good old text messaging. Still fundamental for a lot of things, including sometimes authentication.
Indeed. Wow. Okay, that was quite the list.
It was. But hopefully breaking them down like this helps. You see how they all fit into different parts of the tech landscape, from sending files securely to logging into networks to just texting.
Absolutely. They seem less like random letters now and more like, building blocks of the digital world we use every single day, often without even realizing it.
That's a great way to put it. They're often invisible, but crucial. Understanding them, even just a little, gives you a better handle on how things work and how they're protected.
Totally agree. Hopefully that cleared up the alphabet soup for our listener and for you tuning in. Makes you wonder, what other tech mysteries are hiding in plain sight? Let us know what you're curious about.
Ever feel like, the tech world's just speaking acronyms? It's like a whole different language sometimes.
Definitely. So many abbreviations flying around.
Yeah. So today on the deep dive, we're gonna try and be your decoder ring, basically. We've grabbed a bunch of common tech terms.
And the mission is clarity, right?
Yeah.
Cut through the jargon.
Exactly. Give you that core understanding so you can, follow along without getting lost. Think of it as a quick unlock.
Yeah, making them less intimidating. It's more about recognizing what they do, what problem they solve.
Okay, good plan. Let's kick off with security. TTP comes up a lot. What's the core idea there?
Right, TTP. It stands for Tactics, Techniques, and Procedures. So instead of just knowing what happened in an attack, TTPs tell you how the attackers operate, their methods, their tools.
Ah, okay. Like understanding their playbook.
Precisely.
Mhm.
And that insight helps security teams predict things better, build stronger defenses. It's really crucial.
Makes a lot of sense. Okay, what about WA? Sounds like a wall.
It kind of is.
Yeah.
A WF is a web application firewall. It sits in front of your web apps.
Like a gatekeeper.
Exactly. It checks the traffic coming in and blocks malicious stuff, things trying to steal data or mess up your site. Super important for anything facing the public online.
Got it. And then there's XDR. That sounds broader.
It is. Extended detection and response. Think bigger than just one computer or server. XDR pulls together security info from, everywhere. Networks, cloud, endpoints.
So like a central hub for security alerts?
Yeah, pretty much. It gives you that bigger picture of an attack and helps coordinate the response much faster. Connects the dots.
Okay. While we're in security, maybe quickly touch on Wi-Fi stuff. WEP, WPA.
Sure. WP, WPA, and now WPA23. Those are Wi-Fi security protocols. Ways to encrypt your wireless connection. WPP is old and insecure. WPOP23 are much better. WPS is a Wi-Fi protected setup meant for easy connection, but sometimes has vulnerabilities.
And wide swips.
Right. Wireless intrusion detection system and wireless intrusion prevention system. They monitor the airways for road access points or attacks, specifically targeting Wi-Fi networks. Detection versus actively stopping it.
Okay, and last security ones, XSS and XSRF, they sound similar.
They're both web vulnerabilities, often confused. XSS, cross-site scripting, lets attackers inject malicious scripts into websites that other users then view. XSRF, cross-site request forgery, tricks a logged-in user into performing actions they didn't intend to. Both are bad news for web security.
Right, good distinctions. Okay, let's switch gears to networking. VPN, probably the most familiar one here.
Yeah, most people have heard of VPNs, virtual private networks. The big thing is creating that secure, encrypted tunnel for your internet traffic.
Especially vital on, say, coffee shop Wi-Fi.
Absolutely. Protects your data from being snooped on. Also great for accessing work networks remotely securely.
Okay, now VLSM. Sounds a bit more technical.
It is, a bit. Variable length subnet masking. It's all about using IP addresses efficiently. Instead of giving fixed-size blocks of addresses, VLSM lets admins create subnetworks of just the right size.
So less waste.
Exactly. Conserves those valuable IP addresses, especially important with IPv4 running out.
Gotcha. And VPC? That's cloud related, right?
Yep, virtual private cloud. Think of it as your own private, isolated slice of a public cloud provider's network.
So you get control, like your own data center, but in the cloud?
You got it. Control over IP addressing, subnets, routing, but with all the cloud flexibility and scale.
Okay. And quickly, WAP.
Wireless access point. That's just the hardware device like your home router that allows Wi-Fi devices to connect to a wired network.
Simple enough. UTM.
Unified threat management.
Yeah.
These are often hardware boxes that combine multiple security functions, firewall, VPN, intrusion prevention, antivirus, all into one device. Sort of an all-in-one security solution, often for smaller businesses.
Makes sense. Okay, moving into more general tech and processes. URI. We see URL all the time related.
Yeah, very related. URI is Uniform Resource Identifier. It's the general term for any name or address that identifies a resource on the internet. A URL, Uniform Resource Locator, is the most common type of URI, specifying how to get to the resource, like HTTP or FTP.
Ah, so URL is a specific kind of URI. Got it. What about UEFI? That replaced something old, didn't it?
It did. It replaced the old BIOS system that used to boot up computers. UEFI, Unified Extensible Firmware Interface, is way more modern.
Advantages.
Faster boot times, better graphical interfaces, supports larger hard drives, and crucially, better security features like Secure Boot. This is standard now.
Okay. And UEM sounds like management.
It is. Unified Endpoint Management.
Mhm.
This is about managing all the devices connecting to an organization's network, laptops, phones, tablets, everything from a single console.
Ah, keeping track of everything and keeping it secure.
Exactly.
Yeah.
Simplifies IT's job massively and helps enforce security policies across the board.
USB OTG. That's on the go.
Yep, USB on the go. It lets devices like smartphones act as a USB host, so you can plug in, say, a flash drive or a keyboard directly without needing a computer in between. Pretty handy.
Cool. UAT, that sounds like testing.
User acceptance testing. It's a really vital step before software goes live. Real users test it out to make sure it actually works for them and does what it's supposed to do in their real-world environment.
So the final thumbs up or thumbs down from the people who'll actually use it.
Pretty much. Catches issues the developers might have missed and ensures the software meets the actual business needs.
XML.
Extensible markup language. It's a way to structure data using tags, similar in concept to HTML, but XML is more flexible and used for storing and transporting data, not just displaying it. Very common for config files and data exchange between systems.
Okay. And maybe just quick mentions. WO.
Work order, just a standard document authorizing a specific piece of work to be done, common in IT service management and maintenance. Transaction signature, used in DNS, the domain name system, to securely authenticate updates between DNS servers. Helps prevent unauthorized changes.
Nice OR. That's like basic computing.
Yeah, exclusive OR, a fundamental logical operation in computing. Output's true only if the inputs are different. Used everywhere from basic calculations to cryptography.
WTLS.
Wireless TLS, an older security layer designed for wireless networks, kind of like TLS SSL for the web, but largely superseded now by standard TLS used over Wi-Fi with WPA23.
Wow, okay. We covered a lot of ground there. That really does help demystify some of that alphabet soup.
Yeah, hopefully it feels a bit less like a foreign language now. Just knowing the basic idea behind each one can make a big difference.
It's like you said, they're the building blocks for understanding bigger tech concepts.
Exactly. They pop up everywhere once you start looking.
So for you listening, maybe think about which of these sparked your interest. Was it the security side, networking, the cloud stuff?
That curiosity is a great starting point for digging a bit deeper on your own.
Absolutely. Well, that's our quick decode for today. Thanks for diving deep with us.